Space Station Freedom, the next step in our continuing effort to explore beyond Earth's boundaries. As we establish a permanent presence in space, new medical challenges will have to be met. With longer missions, larger crews, and the complexities of a medical rescue, the health of Freedom's international crew will be essential for the success of this program. The Crew Healthcare System, or CHECS, is currently being designed and developed primarily at NASA's Johnson Space Center. Distributed throughout the space station, this system will provide the total spectrum of crew health care with 3 distinct but interconnected components: the Exercise Countermeasures Facility, the Environmental Health System, and the Health Maintenance Facility. Following is a description of the Exercise Countermeasures Facility, or ECF component.
The thrusters seem to be working good. Yeah, they do.
In space, the human body is not working against the forces of gravity. As the body adapts to weightlessness, skeletal muscles shrink or atrophy, and bone structure changes. These and other physiological changes are part of the deconditioning process resulting from the effect of zero gravity. Exercise can be an extremely effective countermeasure to deconditioning. The Exercise Countermeasures Facility will provide a comprehensive exercise program so that future astronauts can remain physically fit during extended stays in space. 4 different laboratories at NASA's Johnson Space Center are working on the Exercise Countermeasures Facility: the Exercise Development Lab, the Exercise Physiology Lab, the Anthropometry and Biomechanics Lab, and the Artificial Intelligence Lab. Products from the combined efforts of these labs will include special exercise equipment, individualized exercise programs or prescriptions, medical monitors, and computers designed to integrate the system. The Exercise Development Lab specializes in the operational and logistical concerns of exercising in space. This lab is also responsible for development and integration of exercise hardware and software with exercise protocols. Equipment currently being considered for use on Space Station Freedom includes a treadmill, a combination bicycle rowing machine, and a resistive exercise device. The Exercise Physiology Lab is developing individualized exercise programs or prescriptions for crew members. This lab is also evaluating the effectiveness of exercise programs in preventing or minimizing deconditioning. The Anthropometry and Biomechanics Lab is evaluating and establishing the biomechanical effectiveness of exercise equipment. This will help determine how well the human body interacts with the equipment in zero gravity. Development of the biomechanical requirements for intravehicular and extravehicular activities is also done in this lab. The Artificial Intelligence Lab is responsible for establishing requirements for database management, data analysis, and developing automation of the exercise protocols aboard Freedom. A computer-controlled expert system using an artificial intelligence program will be able to automatically adjust each astronaut's daily exercise regimen. In order to test the exercise equipment and verify the procedures prior to trials in space, Several methods are utilized on the ground to simulate the microgravity environment. One method uses JSC's weightless environment test facility. Here, neutral buoyancy is used to simulate microgravity conditions. Another method used in testing is NASA's KC-135, a modified Boeing 707 airplane. The plane is flown in parabolic arcs to create approximately 30 seconds of near weightlessness at the crest of each parabola. Dr. Bernard Harris, head of the Exercise Countermeasures project at JSC, explains the overall goals of the project.
Basically, there are two types of exercise that will provide for extended duration flight. Aerobic exercise, which will be used for cardiovascular conditioning, and anaerobic exercise, which will be used for muscle and bone conditioning. Providing exercise training in the microgravity environment will provide us a tremendous challenge. Without gravity acting on the body, we're going to have to design restraint systems which will actually hold the astronaut to the exercise equipment. With extended duration missions, we're concerned about the psychological welfare of the crew and the physiological aspects. For this reason, we have designed a motivational system to be used in conjunction with the exercise facility.
Exercise in space is more than staying in condition for the return to Earth's gravity. It is the key to good health over prolonged periods of weightlessness. As part of the crew healthcare system, the Exercise Countermeasures facility is being developed today to provide an exercise program that will improve pre-flight, in-flight, and post-flight physical fitness for tomorrow's astronauts.